So last time we were talking about coupling, right? So we're talking about coupling, and we're talking about control coupling, right? And we talked about passing the flag in, right? To actually control what the function does. And so the solution was to separate into separate, methods. And we talked about, well, the difference between doing a computation versus, trying to control what's going on. And then, of course, there's always this problem of, it's engineering. It's not like, oh, you always do it this way, you never do it that way. You have to figure out what the consequences of each way are doing it, right?
Mark and I were actually talking about this right here, this 950 settings. So if you had to go back to that, would you just implement like a strategy pattern then in that case and just handling 50 settings?
Well, the problem is you may want the same program to do it, switch frequently, right? Then do you want to use a strategy pattern to do that or not? Because then you have to inject that strategy each time.
As you said, I think I remember you said that the strategy pattern is not constantly switching or changing.
It can change, but usually, the state pattern switches more frequently than the strategy. But we also get control happening in the other way, right? Is a method or function returns a value to, then we decide what to do based on that. And this is in C. This happens all the time, right? What do you do in C? Well, it's like, okay, we're going to do something, and if something went wrong, we're going to return -1 or 0 or +1, right? Then you decide, well, okay, I guess it fails after this, it succeeded, so I could go on and do that. Right? So we return, the result, and we look at what the result was and decide which path we're going to take. So of course, nowadays we have exceptions, right? So we can, right, instead of returning a flag, say, doing this, return exception. And again, it makes things a little more explicit because now, if we're in Java world, then the signature says, oh, I can throw this exception, and we know what we have to deal with, right? The other thing is when you're passing a flag back like that, what happens if you actually have to return some data, right? So your flag has to be out of bounds, like the flag has to be -1, and all your data has to be positive numbers. So what happens if your data could be negative? Oh, we can't use -1 anymore. We have to do something else, right? Whereas with exceptions, okay, there's two separate channels. One channel is return result, and then we know it's the actual value. And then exception is the other route. And of course, Java really stressed out people with their exceptions. How many people here in Java will do like, oh, there's 3 exceptions, so I'll just catch exception, right? And then it's like, what do? I don't know what to do, so I'll do anything, right? And then it's like the whole point of it goes away because like, okay, part of the problem is we get so many exceptions, you have to catch this and this and this, and now what do I do? And the more, in reaction to that, people started to create optionals. So an optional can either be a real value or a non-value. And so when you would have thrown an exception, you would return a non-value. And so there's an example is, okay, when you convert a string to integer, if the string really is representing a number, we can do it. But when you call that function, if you pass in the string cat, you can't convert that to integer, right? And so what can that function do? Well, in the Java world, you throw an exception, but in modern language, you'll return an optional, and it'll return in the non-value version of the optional. And then when you get that back, you can then continue on calculating, doing what you want, but at some point you look at that thing and say, oh, is it real value or not? So here we can, this can't, so we just return the non-value, right? And so the optional either has a value or doesn't have the value, and it's popular enough in languages now to introduce it in Java, right? Java now does have optionals, but the using exception is so ingrained, right, that people are not going to change. And then, this is Swift syntax, but you declare, oh, the question mark indicates that could be an optional, right? So either it has a value or doesn't have a value. So yeah, we take the string and you convert it, but then we have to check, right? Does the value exist or not? And so there's this crazy syntax where we do if let, and if the value does exist, then the if statement is run, and the int has the actual value, and if it wasn't a value, then we execute the else part. And in Swift, they also give you a way of converting an exception into an optional, right? So, the top part, is throwing, but if we just put try in front of when we call it, actually converts that exception into an optional. So we can actually not deal with exceptions and just deal with optionals. And the one thing that often happens is, some low level, something goes wrong, like convert it into a string to an int, right? It goes wrong, and then you're doing all those calculations later on, and it's not until you're at a much higher level you can decide, okay, I better ask the user for something else, right? And so what you'll see happening is with these optionals, the optional can propagate all the way back up, right? And do this calculation, well, oh, it's null, so I return another optional, You keep on returning optional until finally, like, okay, something went wrong down there, so now I'll decide what to do. So you'll see them propagate. And a lot of people talk about railroad programming in the sense of there's two tracks. The one track where everything's good, but at some point something goes wrong and then you jump on the second track. And when you come to the end, you say, okay, now I have to do something different, right? Something went wrong, what do I do? And usually there's multiple places where you check for the optional, oh, it's no value, so something wrong, and go down the second track. Languages changes, they evolve over time, so it's just it's a part of reaction to Java's overuse of exceptions. People got tired of try, catch, 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 try, catch, 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 right? And of course, they're just replacing it with if let. The going from weakest to strongest coupling. The next one Bernard came up with is global data coupling. Now the problem with these statements is that we don't think about them, right? Oh, they're bad, right? Um, but we don't. If they're so bad, why do we have them in every language? It's like, um, what are these? I mean, system.out is a global thing, right? And inner.max value, that's global value, right? We all languages have some way of turning to standard out, right? And that is global, right? And it's useful. And of course, both these values are constant, like they're static finals, so you can't change them, which is slightly different than having a global value you can change. So yeah, in general, we don't want to have globals, but they do have their roles. And so he categorizes them right in terms of how bad they are. So reference an object, right? Um, standard.out is referencing an external object, right? Um, well, and then standard out, we're going to call print or print line on it. So we're calling methods on it, but we're calling um, public methods. No, then that if thing remains constant, right? Public interface, um, they don't change. So that, yeah. So now if expose how it's implemented, right, then that can cause problems because if expose cells are implemented, then we can't change them in the future. We're not doing hiding. Oh, as an aside, early on in Java, system.out was not final. You could actually modify it. And early on, there was people on Stack Overflow were saying, "How can I wrote to send it out, but now I want to write to a file. What do I do?" And the answer used to be, "Oh, just get a stream that writes to a file and assign it to system.out, and it works." But you can't do that anymore. Um, yeah, so what happens when that global thing changes state? And that becomes more dangerous because now you don't, when it changes state, if it's in the wrong state, where did that change come from? It's harder to tell because anyone can access it, right? And then, okay, the state's not, can change and people have access to the state of that object. But for me, again, it's one of these things where we like to talk about the absolutes, avoid globals, right? They're bad, they're evil. Um, yeah, but there are times when we need them. Um, and so again, he's trying to elucidate, okay, you know, which one has more bad side effects, right?
Isn't the whole idea of global variables kind of mesh well with the notion that you're not supposed to write once as well? Like if you know you're going to be using a value throughout your program, for whatever reason, it makes sense to make it's just going to be referenced all over the place and in different scopes. And
Yeah, but you also have to ask the question, um, am I making it global just because my architecture is so poorly done that I can't, pass that value around where it's needed?
so you're saying that in general, well-designed software shouldn't really need that many global variables, except in the cases.
Um, yeah, but let's look at an example, right? In Java, whenever you run a Java program, there's a security manager, right? Um, it's better known when you run an applet because you realize, okay, you're running an applet you download from the internet, you want to restrict what it can do, right? But there's also a security manager that runs anytime you run a Java program on your machine. It's just that when the code is comes from your machine, the security manager is more lenient than when you download the code from to a machine. But in that case, number one, we want to make sure there's only one security manager, right? Because otherwise, if a programmer can inject a second one and use it, then there's no point, right? But that there are many places in the Java library where they need to check: can I read a file? Can I access a stream in a network? Can I, you know, there's many different places in the library where you need to check to see whether or not um, the current code should have access to that resource, right? And so in that case, there's no way to architect the system to pass it around because you're using different disjoint libraries, right? And so that has to be global, right? In every Java program, done, right? And later we'll talk about the singleton pattern, where the whole point of it is to make something globally accessible. And then you get these arguments, singleton pattern is evil because it's global data, but I mean, if you want a security manager, right, and you only want one, and it has to be accessible, and it has to be global, right? We're stuck. I mean, so it really depends upon the problem you have to solve. Um, internal data coupling, when one module directly modifies local data of another module, right? So in C++, there's things called friends, and you say this class is a friend of that class. What that means is this class can access and modify the private data members of this class, right? Both Smalltalk and Java have reflection, where in reflection, you can actually access and modify the private fields of this class. And then, of course, there's Python, or there's right? There is a hack Python programmers use to try and make their fields private. But ordinary fields can be accessed anywhere. Now again, right? He says this is the strongest, least desirable. Oh yeah, and the Python. I mean, the Python people are like, well, what's the problem? I mean, does it really matter that you can access those fields? Um, just make sure you hire good programmers who don't you trust your employees? I mean, if you don't trust them, why'd you hire them? I mean, and literally that's the argument I've heard. People on the next side like, if you don't trust your programmers, you have a much bigger problem than just having someone accidentally, right, muck with something they shouldn't. But even though this is supposedly the worst type of right coupling, the strongest, we still need it. How do you implement a debugger in Java? I mean, you need it, right? I mean, you want a debugger, you want to step through your program, and you want to see the values of the fields of those objects, right? But they're private. So how can you see them? You need to be able to go behind the scenes and right. And so using reflection in Java, we can access those values and see what they are, right? And actually change them, right? You rarely want to do it, but here's an example where it's absolutely essential, and you really want it. I mean, it's a major improvement over just print out this, print out that, right? You can step through the program and see what's going on step by step. So even though this is supposedly the strongest and the worst type, we do need it. And there's content coupling. Some or all the contents of one file included another one. If you mainly program in Java or Python, you have no idea what's going on. But in C world, right? In the C++ world, particularly in C++, you got the header file and the implementation file, and it's sort of, I mean, you can actually put implementation in the header file if you want, but to actually use it, you always have to include that header file where we want to use it, and then you can get it included multiple times, and yeah, if you use if-defs, everywhere, yeah. I must say I'm glad I don't have to deal with it anymore. What's really fun is when you have C++ generic classes and including them, they include a bunch of other ones, and at some point, it's like, the program won't compile anymore. Why? I don't know. Try different C++ compilers. Like, what? I mean, how can that be an answer to your solution to me trying to run your code? Is I need a different C++ compiler? Maybe. I mean, right? So that's coupling, right? So ideas in coupling, which is again how things are tied together. Bunch of references. Cohesion, right, is the degree to which tasks performed by a single module are function related. How well does all the pieces in your module fit together? Do they belong there or not? Right? The battery no longer lasts for an hour and 15 minutes, so I have to. Yeah, but it's expensive. It only takes like 2 or 3 minutes for it to get fully charged. So, yeah, so different people have different definitions what this sort of means, right? How well things belong together, how fit together. I mean, look at the abstraction. Do those things belong to the same abstraction or not? You know, having a priority queue where you have a print student, like, that part's not very cohesive, right? I mean, it doesn't really belong to that abstraction. No, having a method called print student in a priority queue, right, is not, it's not part of the abstraction, so that makes that class less cohesive than it should be. What's that? Having, you ever get a priority queue and you have a method called print student in priority queue? What's that? Yeah, assignment number 1. What does this play text have to do with a priority queue? You know, priority queue has certain, it's an abstraction, right? It's a data structure that we study, you can study in, 310 and algorithms course. And they talk about you add things, you remove things, you can clear it out, you can ask how many things are in there. But the main operation is things have priorities, and when you pull something, you can get the top priority, right? And so abstraction doesn't talk about printing things out or displaying things, right? How to achieve that? If you were going to print things out, well, we can add an iterator to the class, right? And that, then we use that, but it also, having an iterator on a collection, again, that's a common operation you want to do in a collection, right? So if you want to print things out, we add an iterator to it, and now we can use iterator. And you want to print out the standard out, we can do that. If you want to print it to this, in a GUI, we can do that. You want to print it to a file, right? Now we have the flexibility. Whereas as soon as you have display text, you have to decide where you're going to display it and how you're going to display it. And that's not part of the abstraction of the priority queue, and that makes that class less cohesive. That piece really doesn't fit very well.
Well, like at least in the context of assignment 1, there's like no obvious place for it. It's probably.
Yeah, it was a design question, right?
Yeah.
And yeah, part of it, I didn't ask you to write a program. And so in some sense, it was, I was tricking you into, but the goal was to, sort of look, I mean, your natural inclination was to do it this way, and that's not how you want to do it. So he comes up with, a slightly longer list of different types of cohesion. This time going from worst to best. Coincidental. It's just, there's no relationship, right? It's sort of random. And so you might say, I need these 10 operations in my project, so I'll make a class, and every class will inherit from that. Another way you see it is like, I came across a bunch of stuff I that's useful and I need, but I don't know where to put it. So it's like, like the junk drawer, right? We all have a junk drawer. Like, where does this go? It goes there. It goes there. I have no idea where this goes. put it in the junk drawer, right? So it's a junk class, right? For things like, I don't know where it goes, so I'll put it here. And so these things have, I mean,
Random, like,
they're random like things, right? Yeah. What's that? Called it utilities. Yes. But what does that mean, right? It just means useful stuff that I don't know where to put. And sometimes in Java if I have a string operation, where can I put it? I can't put it in a string class. And so you get utility classes, right?
you have this to go the data function, store data,
Yeah.
get data. So this is the right place for that to be. It does not operate on any data.
Yeah, so the question of what do you do when you have this one little thing that doesn't fit anywhere? Well, the first thing you want to ask yourself is, what abstraction might it belong to? Because it may be that you're just missing an abstraction you haven't thought about yet that would be useful, right? So that's the first thing you want to do.
We figure out if it's useful.
No. There may be it may be a particular instance of a useful abstraction, but you haven't thought about that abstraction yet. And once you think of that abstraction, you realize, oh wait, it's not just one thing I want to do, but there's 3 or 4 things I want to do, right? And indeed, your example, um, people have been doing this for a long time. It's like, how do I do all this SQL stuff in my program? Do I really want to embed those strings everywhere? No, I don't. And so, what's some abstraction? And so there's,
Separate class for program.
yeah. And so there are lots of ways you can think of that idea, right? Um, I've heard of active record, and in the Microsoft, they use it a lot. That's an attempt to, right, sort of be an interface between your code and the database, right? To hide, right. Um, so in that example, right, it wasn't just one thing. It's just that you didn't think about, oh, this is a general problem, and how do I solve that general problem?
First thing, if this new thing fits better, its own module, its own read, read.
Yeah. To Now, it may be that if your project's small enough, it doesn't make sense to build, right, an active record class. Um, and so you may just say, oh, okay, it's a small thing I'm going to put over here, and maybe later I'll build on it. Um, but your first impulse should be, yeah, what is this thing? What sort of abstraction does it belong to? What makes sense? Um, Logical cohesion. It's just basically the flip side of control coupling in the sense of, why is all this stuff together in the one method? in the lamp example, it's there because you want to turn the lamp on or turn it off or blink, right? Um, and so instead of having all this different stuff in the same place, we can, same solution we had in control coupling, we break into separate functions, and then we're not we're not combining a bunch of stuff based upon that control flag. Sure, I mean, the reaction to what if there was 50 of them? Well, do you really want 50 methods or not, right? Temporal cohesion, things have to happen at the same time. A common example of this is the program starts up, and so we have to, a lot of things have to happen at that point, right? All these things have to be initialized. We have to read a bunch of config files to get the data and do this and this and this and this, right? And so we can just do it all happen at once, right? So these are the common situations when you initialize things, or when your program, when you hit quit, right? Then you make sure lots of things are shut down and files are closed and all that sort of stuff. Common solution is each class should have a constructor and a destructor. So why is this better than having this one initialize method? Well, the initialize method will be called, right, and startup, and yeah, it's the standard way of doing things, but why is it better? Well, if we're talking about initialization and shutdown, then memories aren't a problem because when you shut down, it's all cleaned up.
Okay. That no one whereas I was separate initially.
We've got one initialize method, and we put it in main. First, main line 1 call initialize. The effective destructor. Well, the main use in Java is to make sure that you close files, um, close any sockets, any data that you want saved, either file or database is saved. Yeah, that's in Java, that's usually taken care of. Yeah, in the Java world, destructors usually used to clean up external resources, right? You get an open file descriptor, you should close it, right? You have open socket, you should close it.
But then you said
Yeah. If I have a method or a function that initializes my program, well, I have to do something over here, right? Set this data, and I have to set this data over here, and then it comes over here, and it has to set this one up, and it has to set this one up, which means it has to know about this thing over here, right? And it needs that piece of information. And then it has to know about this thing and this piece of information. And this has to know about this and this and this, and pretty soon this thing has to know everything, right? Where using the constructors, oh, you're hiding what I have to do over here, right? I can just call the constructor, and it deals with all the details, right? So we're hiding the details and so we're not assigning all this stuff directly, right? You may pass off part of the config file to the constructor, but what's that constructor doing? I don't know. I mean, there's a bunch of stuff. I don't have to worry about it. What's this constructor doing? I don't know. If I do it all here, I have to know. Right? So we're allocating responsibility to the constructors, right? So this initialized thing has to do less work. All it has to do is, read the config file and pass off the right data to the right place, and all things are good. Rather than having to know all the details in one spot. Having one spot in your program that has to know lots of details about the program is usually asking for trouble. Why? Because as your program grows and is more complicated, that one spot has to grow and becomes far more complicated, right? Because that's not everything. So that's why using constructors is better than having this sort of one initialization place. This is my favorite. Finally we get to talk about this one. Group processing elements based on procedural or rhythmic relationships. The reason my favorite is, okay, we have a program to write, we have an assignment, and what do I have to do first? Oh, first I have to do A, and then I have to do B, then I do C, and then I do D, and then when I'm done, I get to do E, right? And like, okay, and then you think about it, okay, I got A, yeah. Now how do I do, oh yeah, and then the B, how do I do B? Okay, I think about that. I can sort of do B, right? And C, okay, C, how do I do C, right? So eventually get in your head, there's a linear sequence, A, then B, then C, then D, then E, right? So when you write your program, what do? We start with A, right? Yeah, and then they're like, okay, but wait a minute, I should be using classes, right? Oh, so what do? Maybe class A or class B, but at some point, like class, what do I see? Oh, I can put one method in class A and one method in class B, and right? But then what happens is your classes aren't very cohesive because there's like, I need a place for A and a place for B. And we get the program, it's just basically one main function. It should be A, B, C, but you sort of hide it, right? Because it's supposed to be classes. And so what happens is these applications become very specific to your application, right? Your classes are just Why do you put a print statement in a priority queue? Well, because the requirement said we need to print things out. And okay, so they're in the priority queue, so just print it out there, right? Why not? Because it's not very cohesive, right? And that causes problems later. And when you come back and look at it, it's like, why is there a print statement, print students in a priority queue? It's like, that doesn't make any sense. But in the context of what you're doing, right, it's A, B, C, and D, and I'm doing D, and where would I put it? Well, it deals with the priority queue, so I put it there, right? And so this is a previous assignment where you get this linked list, and okay, add, get, that makes sense. Print students on probation? What? I mean, it doesn't make sense. But when the assignment was to build a linked list, right, that holds student objects and their grades, and we need to know who's on probation so we can send letters out to say you're in trouble, right? Then this type of procedural cohesion, that's where you get procedural cohesion, right? We're just thinking about A, B, C, D, E, right? And so for me, when you're writing programs object-oriented way, we've got two roles we fill. One is we have a program to write to get something done, right? We need a priority queue. We need wait lists, right? So we need a wait list system, and so we need a priority queue. So students can be added to a priority wait list, and when someone drops a class, we get the right person to add. Otherwise, the students go crazy, right? You don't want random people getting into class. You want some sort of system. Of course, they don't tell you how you prioritize it, so it seems random, but it's not. And when you're just doing the program writer, you get this procedural cohesion, right? The other role is, look, we're programming in Java or Python, and so we have to build classes, and we want to start building classes as building blocks that we can use to make it easier to write this program, right? So if you're building a waitlist system, we need a priority queue, right? And so just build a priority queue, right? So you have to step out of this program writer mode and say, okay, I need a priority queue. So I step over here, okay, what is a priority queue and what should I do? Okay, now I got my priority queue. Now I can back over here and say, okay, now I can use that building block to help implement the waitlist system. When we stick over here, we get this procedural cohesion. And what happens is the programs, like I said, they don't make sense out of that context. And it also means that things aren't reusable, right? Because they're all tied to that one particular program. And so you have to keep that, those two roles sort of separate, right? Because when you think about building a class, it's going, well, we don't want to think of it in the context of just doing what we're doing here. Like, what is a priority queue? Oh, it does this and this and this. Okay, let's get this done, and it'll make my job easier, right? And it's one of these things where, sometimes, a straight line isn't always the fastest way to get someplace, right? If I'm here and I'm right there, a straight line is right? It's not. It's going to be much faster for me to come over here first, right, and then go there, and then go back, right? Um, so when you're writing a program, sometimes the fastest way to complete it is not to stick in this mode all the time, but oh, we need to build build up our tool chest. So when I come back over here, it's an easier thing to deal with, right? Yeah.
If you had to say that, you say like that's specific.
Depends upon the project, right, and what you got available.
But if prefer you want to put the class you have.
Yeah, again, it depends on your library. So I know at one point years ago, I had a graduate student who he was taking a class and it was a big team project, right? And he had a hard time getting students. It's like just stop writing code and look what you got in Java, right? There's all this stuff there. What do you need? What can you use? Because they're just so used to being in that mode, right? They wouldn't come over here and say, "What do I need?" I know. I mean, Java had a lot of things that they could have used, but they just didn't. You know, we like writing code more. We like reading code, right? And sit and look through the Java API and say, "What can I use?" It's like that's boring. Yeah. So all along, right? Here we talk about modules. Um, so prior to doing a program, what people thought what they call the module is really a function, right? Now, in object programming, a module becomes a class. Yeah, but like in a function, you can call multiple functions too, right? Now, when you say a class inside of a class, are you talking about inner classes in Java? Um, Typically, they become very interrelated classes, right? Right. The inner class is intimately tied to the outer class. Um, there are times in Java where it's definitely convenient. It's less work. Um, Part of the time, it's a defect of a language. Other times, it's just more convenient. You know, having lambdas makes a lot of usually these inner classes go away, but not all of them. Um, yeah, this one is a little bit harder to explain and give examples for. Um,
Just like in our priority queue in the last assignment, we had to implement a strategy called priority. So suppose you could say that those strategies operate on the same same
Right.
output, the same thing, but is that the neighborhood?
Yeah, because now what you're doing is instead of having one object knows all the different strategies, we break it in different strategies, right? And then we just send a method to the strategy to do something, right? And that's what it means by polymorphism, right? We basically have um, n different strategy classes, different strategy objects, and we send a method, calculate this. And at the if we're talking about modules as functions, then overloading overloading the function names with different data types, right? Rather than having one function that, oh, is it this type, then do this. If it's that type, do this. Um, yeah, here when I talk about modules, it's a functions, right, not classes. Um, yeah, for this functional cohesion, at the function level, the function should do one thing, right? Just one thing, not three things. Um, and then each object should present a single abstraction. Now the tricky part here is it's always easy to say this. Um, so for example, taking a priority queue and converting it to a string and then printing it out. Um, is that one operation or two? It's two. At some point we need to do both of them, right? So then how do we do that if we can't put them in the same function? Yeah, so the one thing we have to talk about here is levels of abstraction, right? So converting it to a string, right, that is a single function, right? And then printing it out is another one. And then the operation, right, at a higher level becomes one operation. When I convert, print this priority queue out, right? So the higher level, we don't go through the details of how to convert it to a string and then the details of how to print it out. It's like, oh no, okay, we've done that at a lower level. Now at a higher level, it becomes one operation, print this out. Yeah, and here it's basically it's trying to, he's trying to tell you an abstract idea of what a class is, right? One is we got the hiding a concept or data or resource in a single module or single what we call a class now. And then you've got multiple entry points. How do you functions usually only have one entry point, right? Coroutines can have multiple entry points, but they're sort of rare. And each entry point performs a single function. Well, Pacifica says you have a method and a class, right? And it performs a single operation. And all functions are related by a concept or data structure, right? Resource that's hidden, right? Right. So this is his discussion on sort of cohesion, free object style. And then what he does, he wants to look at what type of cohesion can we have in objects or classes.
Can object cohesion be the context, or is it defined in general use? Like, could you have this? I guess the question was.
Yeah, the problem is, again, it's easy to say, oh, a class represents a single abstraction, right? And when we talk about priority queues and stacks, and all the things we talk about in a data structures course or an algorithms course, it's like easy. Why? Because that's our domain, right? We study that, and over the decades, people said, oh, here are common abstractions that are important. Now you go work with Qualcomm, and what are the abstractions in their domain? Well, when you start off, like, I don't know, because, I went to school and got a degree in computer science, and now you want me to deal with chips and communications and, right, all that sort of stuff. So now we have to figure out that domain and figure out what concepts go together. When you go in the banking industry, what concepts are cohesive? And yeah, they said you need technical knowledge on that domain. Because what do we have to do, right? In the banking world, and you can never undo a transaction, right? You always have to have a second transaction, which, right, and they all have to be recorded so that we can always figure out what happened. And right, so unless anyone's happened to work in the banking industry, we're not really qualified to figure out what makes a cohesive class in that domain. And like I said, right, coupling is much easier because it's how things interact, right? We can look at it and say, yes, this class and that class interact. Talking about how cohesive a class is in a particular domain is more subjective. Right, so there's a lot of these are pretty standard questions. You know, does it represent in some sort of concept or not? You know, presumably some of you had an undergraduate oral course, and usually they'll talk about how do you find classes and objects. They'll say, well, the first thing you do is you list all the physical things related to the problem, right? And those become candidates for classes. And so there it is, right? Does it represent sort of physical entity, right, in your domain you're dealing with? Um, and the other thing they say, well, once you've got a bunch of classes or things you think might be classes, write a one or two sentence explaining that class and how, if it's fuzzy, but sort of does this and then it does this and it does this, like, right? We all know what a stack does, right? And we can write a very concise, you know, last in, first out, right? We're done. I mean, we know what that means, right? Um, yeah, does it, the first three are really talking about the overall class. Now we're looking at each method. Okay, how cohesive are they? Um, right? And part of here is talking about, well, um, you might have procedural cohesion, right? Where you built this thing in this context, and then you take it off. It's like, why does this linked list have a method called print students, right, on probation? Um, more questions. Yeah, so he goes on to try and categorize various types of things. Um, and so he comes up with a bunch of terminology to try and to explain what he thinks makes things cohesive. Um, and so he talks about primitive methods, right? Those are, like I said, you can't get them any smaller because it's, right? When you're directly interacting with that structure, and you can't leave the structure half undone, right? You have to, when you add something to the priority queue, you can't stop midway. You have to make sure when you're done, the structure is, and so that add method, you need to know the structure, has to be done. It's also a primitive operation in your priority queue, right? Um, a composite method is, okay, use a higher level. Okay, I'll use 3 or 4 primitive methods to do something, right? Um, how do you do remove all? Well, you just remove, right? Um, then he talks about, okay, we want, what's a set of operations you absolutely need, right? Otherwise you can't perform what you need to do. And yeah, it says that may not be good. I mean, it may be good enough on a theoretical level, right? But it's painful, right? I mean, in theory, there's nothing, Java doesn't give any more functionality theoretically than assembly language does. But no one here wants to write assembly, right? Because it's too low level. And yeah, it may not be good. I mean, it's awkward to deal with. It may not capture the entire abstraction we want. Um, and so a complete set is, larger, captures. Um, so, what does all this mean? We go to Java, right? Um, implement an abstract list, I only have to implement those 5 methods. Right? That's it. And given those methods, all the rest follow. Meaning that is a set of the primitive operations, right? Um, and it's sufficient to implement all the other ones we need, right? It's it's not enough, right? We want more, but that's it's a sufficient primitive set of primitive operations for these particular classes. Here we get a much more useful set of operations, right? So what's interesting is that good enough? Is that what we want? Yeah, but this is a library, right? Equivalent class in Ruby. The equivalent class in Smalltalk. Right, so different language people have asked the question, what is a proper set of methods for these classes, and came up with different answers. And coming from a Smalltalk programmer to this, oh man, it's like, you've got to be kidding me. It's a lot more work to do. Really, starting from this and going back to that, it's like all of a sudden you find yourself in a hole. Like you have to climb for a while to get to ground level. What's that? Um, not that I'm aware of. But yeah, it's a progression, and it's just all these things you don't need very often, but they're just nice. Like, okay, I don't. My goal is to use it to get something done, not to muck with the thing, right? Oh yeah, I mean, no, some of them are like, oh, when you need them, oh, cut pieces where? Oh, that's nice. Oh, when you need it, it's like one line, I'm done. And Java is like, oh, you're parsing this and this and this and mucking with it. It's like, no. Well, that's good enough for today.